Why do brakes feel strong, then suddenly go soft right when you need them most? That scary moment has a name: brake fade. Here's the core answer: braking turns motion into heat. If heat builds faster than the system can dump it, friction drops, gases form, fluid boils, parts deform, and your pedal stops matching your expectations. Every stop is an energy trade. Your car's kinetic energy doesn't vanish, it becomes heat in the rotor and pads. One hard stop is manageable. But repeated braking, downhill, towing, track driving fills the heat bucket faster than air can drain it. First failure mode: pad fade. Friction materials are engineered to work in a temperature window. Too cold, they don't bite. Too hot, the resins and binders change behavior, the surface can glaze, and friction drops, so you press harder for less stopping. Second, green fade, common with brand new pads. Fresh pads can release gases as they heat cycle. That gas forms a thin layer between pad and rotor, like trying to stop while riding on a microscopic air hockey table. Third, and the worst on the street, fluid fade. Brake fluid is supposed to be incompressible. But if it gets hot enough, it can boil and create bubbles. Now your pedal force compresses gas instead of clamping the rotor. That's the pedal goes soft feeling. Heat fade happens when the system can't reject heat fast enough. Rotor size matters, venting matters, wheel airflow matters. Even speed matters. Slow downhill braking can be brutal because airflow drops while heat keeps piling up. Engineers fight pad fade with chemistry and structure, choosing friction materials that keep stable bite at the temperatures the vehicle will see. Street pads prioritize noise and cold performance. Performance pads tolerate higher heat. True race pads can be useless when cold because they're designed for extreme temperatures. Next weapon: cooling. Vented rotors pump air through internal channels. Better vane geometry improves flow. Some cars add cooling ducts to feed the rotor center, where airflow is most effective. Calipers can be designed to reduce heat transfer into the fluid. To fight fluid fade, engineers specify higher boiling point fluids and manage heat paths. Maintenance matters too. Old fluid absorbs moisture and boils sooner. This isn't about more pedal pressure, it's about preventing bubbles in the first place. On the user side, the idea is simple: avoid continuous heat build. Use the car's gearing to help control speed, and give brakes time to cool between demands. Don't test this on public roads. Fade is not a game. So brake fade isn't one problem, it's a heat overload that triggers different failures: pads, gases, or boiling fluid. Engineers win by controlling temperature, airflow, and materials. Next question: why do some brakes squeal even when they work perfectly?